Okay, so let's get started. This is an exploratory online seminar. Thank you for joining. This is online seminar number 104. Today, I'd like to present create custom charts with R script. As you know, exploratory is built on top of R, which R is a data science programming language. Or the data science system. So you can natively access, our functions and our packages and so on. And then one of the benefits is that you can create or like extend the charting capability of the exploratory by writing code. So that's the part that I like to demonstrate how you can store, how you can do, how you can, get that integrated with your nodes and a dashboard. Okay, so let me introduce myself. My name is Kan Nishida, CEO at Exploratory. Exploratory is a company we started it back in 2016 to democratize data science. We have a vision of data-informed decision-making is the key for making world better. So in order to make that happen, we need to democratize data science. So we basically do everything under this mission. Exploratory is a tool, like software UI tool that can help you to do these 5 things: data access, data wrangling, visualization, analytics, and communication by using nodes and dashboard. Data access, you can access to various types of data sources to grab the data. And once you grab the data, you automatically generate the summary views that helps you to understand what the data is at the glance. And then most of the time, before you get into visualizing the data or analyzing the data is not in the format that you want. So you have to do the data wrangling. So Exploratory provides the easy to do UI-based data wrangling, so many variation of operations. Once your data is ready, then you can visualize by using various types of the charts, various types of the functionality that are provided along the charts to visualize the data and find the patterns and the trends. Or you can use analytics like statistical or machine learning methods to find the patterns and the trends that your eyes cannot see. It comes with like a preset of the visualizations. So it gives you the easier more intuitive understanding of what's the model or method that telling. Once you find a good insights, you want to present, you want to communicate with others. So you can use dashboard or note to communicate what you have found, or use dashboard to monitor your key performance indicator or the business metrics, so that when you have a problem, you get notification by the exploratory by publishing the dashboard to the server, and you can schedule and automate that dashboard creation. Okay, enough about the exploratory. Let's get into today's topic. So creating custom charts with R script. So what are the type of the charts you can create? So, like exploratory, you don't have to write any code. You can just use the UI, click on, choose and click, and then, point and click, and then you can get a bunch of charts. However, some of the charts that you see, somewhere that cannot be done as part of the UI, but you don't have to stop there. You can extend the exploratory capability by writing out code. So for example, like a Treemap or Waterfall or a Venn diagram or a clustering diagram and so on. So these are the charts that I want to demonstrate. But the first thing first, how you can start writing code to create the charts. Well, 2 places you can do. One is the dashboard, another is the notes. But before you even write the code, you have to find the R package. Sometimes you don't even have to find the R package because it's already included in the exploratory. Then, as part of the installation, then you don't have to bring in a custom R package or whatever R package you need, right? But if otherwise, then you want to find R package, then you want to install the R package into exploratory. Then you can write R script, mostly you just call the functions. Okay, so I'm going to use this Treemap as sort of example. And then, so let's imagine hey, you know what, I want to integrate, I want to create this chart, but exploratory doesn't have that. So what can we do? The first thing first, you want to find our package. So how are you going to find it? So it's pretty kind of simple. So you just Google it, right? So let's say best way to Google is R, which is our programming language is R, and then a Treemap with that, this case, a Treemap is the name of the chart. So just randomly just Google it, and then there are a bunch of like hits. One of the things you want to pay attention is this thing called CRAN or CRAN. This is a comprehensive R archive network. So all the R packages are archived or hosted here. So this is the official R package website. Okay. And then there are other, information like how to use those packages, what are the available, like, type of things. But main thing is here. So like go to Kuran or CRAN, and then like, this is the Treemap package page, and it has all the information. And the most important thing is the documents. It says a reference manual. So when you click on this one, like you have all the functions along with how to use example. So for example, in this document, there's a Treemap. Usually the same name of the package is the function that you need. Sometimes different, but most of the time. So in this case, let's say like you click on Treemap. And then like you have like all the functions, argument explanation, right? So I'm going to just, let's make it a little bigger. And then also like towards the end, you're going to find, the bunch of, here it goes. You're going to find examples. So for example, this is like a Treemap function. And then like you said, the data, this would be like a data frame name in Exploratory. And then you select like some of the column name and so on. There's a few examples, so you might want to take a look at it. But anyway, the important thing is, so you need to know what function you need and how you write. And then this one is like a document, so it's basically like a bare minimum kind of stuff, right? But here the vignette, this is a kind of our unique thing in R. So there's always this sort of like how-to tutorial kind of stuff. They call it vignette. So for example, like you can click on this and it will give you more, kind of easier, user-friendly explanation. Or you can actually just Google it, and there's a bunch of people in the world that write, how-to note for like various packages in this Treemap as well. Okay, so having said that, now like you want to go back to Exploratory, the Treemap package is not part of the Exploratory. So you want to install that Treemap package. How you do it is like, here I'm inside a project. If you're outside a project, like this, you can click on this R package to install that R package. Or if you're inside, like I was here, then you can go to the project menu, and then like there is a manage R packages. The same thing, and you click on that, and this will open this R package UI or window. And then here under the installed R packages, you can see like that, maybe Treemap might be already installed, then you don't have to install. So you can scroll down, and this is like alphabetically sorted. So if that's the case, you should be seeing around here, like RST, where the Treemap. And then here, TR. So obviously it's not, if there was a Treemap, you should be seeing here, but it's not. So obviously it doesn't come as part of the systemly installed package. Or maybe under the user, these are the packages you have installed by yourself. Okay, and then it's obviously not here. And sometimes like when you upgrade Exploratory and upgrade Exploratory, it depends on which Exploratory upgrade, but sometimes that comes with R upgrade as well. Like R itself occasionally or periodically upgrade. And once the R version is upgraded, for example, let's say from 4.3 to 4.4 or something, then all the packages you installed before become invalid. So you have to click on this update button to reinstall to get up to like the certified version or whatever the compatible version with the latest R. But that's a little bit like, down the road. So if you don't see it, then what you want to do is go to the install new package and then type the package name. Make sure this like, in this case, the Treemap, all small letter or lowercase. So I'm going to you just copy that and then paste it. Or you can type it too, but make sure that you don't misspell it. And then click on the install button. And this is going to basically access into this website, I mean, this hosted server, and then install that package. Looks like install went successfully. So you see like a Treemap being installed, 2.4 version. Okay, so that looks good. And then here it's already checked. That means as long as you are using this particular project that it says R script for custom charts or something, then this package is always loaded. So that means like ready to go, ready to use. If not, if it's unchecked, you have installed it, that doesn't mean you can use it right away. So before you use, you have to explicitly say library Treemap or something like that. I will show you quickly to make sure that package is loaded. Okay, so sometimes you call that function, but somehow like the function is not found or something like that. If you find some error like that, typically that you haven't loaded that package. So two ways, right? Again, you click on this, then that package is always loaded. So you can just type the function name right away. Or you can call library function. So I'm going to show you what kind of the function I'm talking about. Here is the script example. I just kind of basically copy paste from that document we just saw. And then at the first line here, it says library bracket Treemap. So that's the one like I was talking about. You are explicitly calling that package name to load that package in this like sort of like our workspace. Okay, then you can call this Treemap function. Okay, but if you already check this checkbox, then you don't have to even call it because the Treemap is already available. So you can start from Treemap from this line right away. Okay, so now my recommendation is you don't have to check, because if you check, what happens every time you open this project, it loads that package. Sometimes you don't need it. It's not like always you need it. Another thing is, like I said, like when in future, when the Exploratory version upgrade happen, and then that comes with like our upgrade as well, then this package becomes invalid, right? Because it becomes an older version, obsolete version. So then if you haven't upgraded this package itself, then when you try to open the project, you will get the error. But you can click on the OK button to ignore whatever the stuff, you can open the project. But it's a little bit tricky thing can happen. So my recommendation is like unless you really need to do it, like for example, like you use that R package function in some like a data wrangling step, or maybe like some of the data operations, then like you might want to check that. Okay, so anyway, so important thing here now is that like, hey, make sure this package is installed, then we can either explicitly load it or not, you can use it. Okay, so you click OK button. So now we are ready to go. And then like I have this node created. And then like, there are a bunch of like our code already being written that I'm going to demonstrate. But the first thing first, let's get that Treemap shown here, right? So first thing I want to do is create from this plus button, and then select the R script. Okay. And then like, here is the R script editor inside Node. And this is where I can start typing. But most of the time, like, you don't remember like how to write. I mean, you can just, if you're familiar with this, and then you can start writing. But I would recommend just copy and paste from somewhere, like this document, or like this type of vignette has some example like this. Okay, and then this might be, help you like better. So you can just copy and paste, or from the document itself. Okay, and then I'm gonna just come back, and like in my case, I have already copied this, and then like I'm gonna copy the whole thing, and then just paste it here. Okay, so the first line again, it's calling, hey, like we're gonna use this Treemap, like load that package in the workspace. Okay, and then the next thing is, this is actually really the one line of the code is calling that Treemap function, and all these lines are basically, each of them is separated by comma, is the argument. First one is a global sales. That's a data frame name. So let's take a look at this global sales data frame here. 51,290 rows, 23 columns of data. Data looks like this. And then what I want to do is, there is, I think, the market. Okay. And then there's inside the market, there's a region and a country. Okay. So if I want to see that, hey, what is that market? Let's say going here, market ratio, sales ratio by the market or something like that. Then all I need to do is either the bar chart and then select that like market here, and then like y axis, like I'm gonna assign the sales and then sort it, right? And then like now like we know like okay, this is like sales number, and then like Asia Pacific is the number one, Europe is number two, and so on. Or you want to see the ratio, you can even like use that, for example, pie chart. Oops. And then color by, I'm going to assign that market, something like that. Now like we know the ratio or number or ISO chart, gives me the information. Treemap is kind of like a pie chart, right? So it's instead of using this circle like angle view, like you have that kind of square view, and that's the only difference. So let's say like, for example, like if I go to here, and then like I'm gonna just the first one, the data frame name, this index is that basically how you want to separate the square. So let's say like I'm gonna say like market, and then a V size is each square size, each rectangle size. Hey, like I want to use a sales. Make sure like I have the sales column, right? And then like at this point, other stuff is something more like a formatting. So like a palette, what color palette do you want to use? What is the chart title? What is the font size, and so on. And but you can click on this preview to get this rectangle, like a squarish, like a view. Okay, this is a very like basic tree map. But for that, like you don't really need this tree map. Like, hey, you have the pie chart or you have the bar chart. That's enough. However, the one advantage of using Treemap is that you can do like more like a hierarchical view. What I mean by that is like each of that market, let's say like Asia Pacific, there's a China, there's a Japan, there's a Korean stuff, right? So I want to see like what's the ratio inside Asia Pacific. Same thing for Europe, same thing for USCA, like the US and Canada. Okay, so that's the kind of cool thing about Treemap. Okay, so how to do it? So in this data, we have market, but also we have country or region. These are the hierarchy: market, region, and country. So I can assign this a hierarchy. So let's say I want to add like a country. Then this index, you notice this, a C, that means it's like a concatenate, is a kind of like a special thing in the R. But basically inside the bracket, inside the C function, you can actually list multiple entries. Right now that we have only one market, but I can add by after the comma and then column name. So let's say like a country. So now like we have two entries in here. That means it's going to create a hierarchical view. So let's click on the preview. Oops, we got that error. I have to close the double with name with the double quote, and then go to the preview. And then boom, here it is. So not only the market rectangle, but each of that rectangle, now like we have more rectangles or lower level rectangles. So like I can see like in Asia Pacific, in terms of sales, we have Australia is the top, and China, India, and so on. So and USCA, I mean US and Canada is all like almost like a 99, maybe like I don't know, 95% is the United States, and then the rest is Canada, and so on. So it gives you more like a hierarchical view of like ratio or like a ratio view by using that tree map. So sometimes you might want to actually try this package. Okay, so now like you get this one in Node, and that's good. And it says like R script preview at the top. This is because like you're editing that node. So when you go publish or to the server, or you can create a HTML view page by clicking the preview, then you get this kind of view. So there's no like a preview or what was that tab name? Yeah, there's no R script or preview or something like that. You directly have that chart, and then you can have like a text before and after, and so on. Okay, so you see like an error here. That's because I haven't adjusted for this particular node yet. So I'm gonna start fixing this after this. All right, so let's go back to here. We have the tree map diagram here. next thing I want to do is I was using this note as a demonstration, right? But what if like you want to have this in a dashboard, and you can do that as well. So here I'm gonna for that I'm gonna switch the project. Now I have this V10 introduction project. I have the multiple windows. And then same thing, I have the same data called global sales data, exact the same as we saw, pretty much the same. And then here, I'm gonna open the dashboard. Here it goes. Okay, so this is like a dashboard for like a sales data, and then that's cool. And then like I have 2 pages. So go to that next tab and then the first tab. And if I click on run button, and then it generates that dashboard output. It's looking good and looking good, right? Okay. So now like let's say like, hey, you know what? Like under the weekly page, I want to include here the Treemap to gives you more like a hierarchical view of the sales structure of like a market and country. It's the same thing we did. So how are you going to do it? Well, you can go to the edit, right? And then you want to actually go to select a page, whatever the page is. And then like, let's say here, instead of clicking on this chart, if you click on this, then you can select the charts that you have created before. But those are the charts that like the using the existing capability, existing chart types that comes with Exploratory. We are talking about like you want to add a custom chart by writing R code, right? So in that case, you want to select this add text. And this creates a text area. This is basically the same thing as the note. So you click on this like edit text button, and it gives you the same note editor. Here, you will do the exact same thing. So like, for example, like here, under the plus button, you select R script. Now like you get the R script writing area. And then like, again, I'm gonna copy the original script. Okay, and then from here, I want to assign the same thing, right? So the index, this time market, and then comma, double click, double quote, and then country and the size. I want to assign the sales. Okay, and then let's preview it. It works okay, and it looks okay. So click on apply, and then close it. So at this point, this is the edit mode. So you see that like an R code. Like if you type like just a text and you see the text as well, and it doesn't really make any sense. But when you click on run button, it will generate and then produce the output that should be written, generated by the R script code. So here it is. So like now like we have the Treemap chart along with the other charts that comes with Exploratory. Okay, so say either dashboard or not, all you need to do is just select our script under the, let's switch to the note editor. There you go. Under this plus button and select our script. And then now like you are off to go. Okay, so next app is, so now we understand like some sort of like basic flow of like creating the charts with our script. Let's get to like other type of the chart, right? Okay, so first I want to do is like a Venn diagram. So Venn diagram, it turned out there are a bunch of other packages, and one of them is called Venn diagram. It's literally it's called Venn diagram. I think this is very well-known one. Okay. So, but before getting into the Venn diagram, so what is the Venn diagram? So, so something like this, right? So basically, like you have like multiple circles, and then the area is all overlapped. Those are the areas that, for example, like have the same characteristics or something like that. So get to more like detailed explanation. So let's say this is, I'm going to use the United Nations General Assembly's resolutions voting record, and then for this is sample data. Then like United States, Canada, Russia, we have 3 countries, and then like we want to know like how much of the sort of like ratio that United States and Canada vote in the same way like Canada and Russia or United States and Russia. Intuitively, like, I mean, like, hey, maybe like Russia and United States always vote in the wrong, opposite way, right? So maybe sometimes same, but sometimes not, right? But maybe like just a kind of intuitive sense, maybe like United States and Canada vote in the same way that Russia is not. So let's use Venn diagram to see like that ratio or that number of the votes more like a visualized way. So for example, I'm going to make it kind of more simple. So let's say like yes vote, right? If we focus on yes votes, and the United States, Canada, Russia, like, each country voted 6 times for the yes, right? So like each side decided. Now, like we want to have these circles overlap each other based on like how much of the same voting that any combination have, right? So what that means, let's say the United States, Canada, yes, yes, and then, it turned out 4 times, right? And then so therefore, we want to place those 2 circles overlap in a way that like overlapping area represent 4 and the other areas 2 and 2 in the United States and Canada. Same way for like Russia. And also like United States, Russia, and Canada, all countries said yes. It turned out there's a 1 time out of those votes. So overlapping area represent that number. So then can we place those circles? And that's what this like Venn diagram really does. Okay, so let's take a look at it. This is the basic one. So here's a Venn diagram with the code I already copied here. Now, we have to prepare the data. For this one, preparing the data is the key. Like coding that package is the easiest part. So I'm going to open this UN voting data. Okay, so again, here's Canada, Russia, USA. Then we want to create that this type of data basically here, sort of like an aggregated way. This is the kind of data we want to create. Okay, so let's start. So what I want to do, not just a yes, but even a no, like if they vote in the same way, how many times they voted out of order of this. That's what we want to do. So what we want to do is the 2 steps. First, we want to count those votes that 2 countries, any combination, voted the same way as a true. Okay, and once we create that data, then we're going to summarize to have just 1 row of that data. Of counting those. So what I mean is, so first let's do like Canada and Russia. Canada and Russia. Before that, like I want to actually remove this like NA, because if it's NA, like, it doesn't really matter. So you don't have to, but like I'm gonna just make it simple. So like remove NA, and then so now like Canada's NA is gone, and I want to do the same way for Russia and then USA as well. So I'm gonna just remove NA for Russia, and then USA, remove that. And then now like we have the 2,861. So these are the assembly resolutions that like all countries said either yes or no, because like sometimes the countries go absentee or absence or something like that. So anyway, so now like what I want to do, like I want to see when how many times Canada and Russia voted the same way. Doesn't matter yes or no, but in the same way. So what I can do is kind of simple, create calculation standard. And then here, I'm going to say 2 equal sign, and Canada and then Russia. So this means value of Canada column and the value of Russia column the same. And then it will return true, otherwise false. Okay. Then the column name is like a Canada and then Russia. Okay. So now here it is. So Canada and Russia, no, the first row, and then true. Second one, the Canada says no, the Russia says yes, so therefore it's false. Okay, so and so on. And I want to do the same thing for Russia and USA as well. So let's do that. So create a calculation, standard, and Russia, 2 equal sign, and then USA. And this one is called Russia and USA. Okay, boom. And we got that. And then now the next one is I want to do the same thing for USA and Canada. So that's USA and Canada. And this one is USA, Canada. Okay, boom. Okay, so now we have 3 combination columns here. And then we want 1 more. You remember like we had this here. All those 3 countries vote in the same way. So let's do that. Canada and any column is fine. All we want to do is Canada and then Russia, the same, and Canada and USA, the same. So that means all countries voted the same way. So here, Canada Russia, USA. Okay, boom. And then like, so we have the 4 columns created based on, like if they voted the same way or not. So we have that data, and then like after this, we want to aggregate before we give the data to that Venn diagram package. So what I mean by that is what we can do is create, we do the aggregate or summarize. And then we don't need a group for this one. So just one row. And then the first one, what we want to do is number of rows. So this is going to be called Canada. Okay, not how many votes Canada did. And the same thing, this is kind of a weird you might think it's a little bit stupid, but bear with me. Like you want to actually create the country columns. So what I'm doing here is USA. And then when you preview, you get 2,861 for each country. And then, in this case, all the countries, exact number. If you focus on the yes number, you can actually conditionally count that number, then you might end up like getting different numbers. But for this case, all of the countries the same way, especially we removed NA. If we didn't, number would be different. Anyway, so we have that. So this is a kind of a format that you have to prepare before you give to the Venn diagram. That's which expect this format. From here, what you want to do is, okay, so first Canada, Russia, and then the default function is number of true. So when you click on it, so this is 1,371. These are the number of the records that Russia, Canada voted the same way, either yes or no. Okay, and then next one is Russia and USA. And the next one is USA and Canada. And then last three, all 3 countries the same way. And I click on the preview, boom. So these are basically the data we needed before we give that to Venn diagram. Or another word, Venn diagram really is visualizing this data by using the circles and the overlapping circles. Okay, so I have that created. Then now it's ready. So let's give that to Venn diagram. So going back in here, and then now like I have to assign the columns and data frame correctly. So data frame name, first I have to say here, UN voting, that's the data frame name. And then we have the column called USA, right? And then CAN, Canada, Russia. This is gonna be like a circle 1, 2, 3. And the circle next one, N12, that is a circle 1, 2. So like USA and Canada. So we have the USA underscore Canada column. Make sure like we have that. And then the Canada, Russia column. Okay, we have that Canada, Russia column, and the USA and then Russia column. And that we don't have it. This one is actually Russia, RUS and USA. That's like a circle 1 and circle 3. And then the last one, all the columns, right? So this one, like I call it CAN and then Russia and USA. Okay. So these are like 3 overlapping area. And then the categories, the circle 1 is the United States, circle 2 is Canada, circle 3 is Russia. Okay, I hope this is working okay. So let's go preview and nothing is showing up. Oops, something is not right. So let's check it out. Voting UN underscore. Oh, this, I was misspelling here. This one is a voting. So only V is uppercase. So I have to change this data frame name. Boom. Data. Okay. And click on the preview. Whew. Now it works. Okay. So now like we have that Venn diagram and then it's all drawn correct. Okay. However, I'm sure you have noticed something weird because when you look at this, like this area, let's say like this area was a 65, right? This like Russia and United States and voting the same way. But this one is Canada, Russia voting the same way, 620. And how is that possible? This 65 and 620, the size of the area is exactly the same. right? So this diagram doesn't care about that, matter what's the value. It just gives you like the idea that hey, this 620 means Canada and Russia overlap, but you're not United States. Okay, so just that concept. But if you want the area, each area, including the overlapping area, to represent the value itself, then you want to use a different package, which is this one called EULERR. EULA R. So that last one is like an R package R, so like EULA. And it turned out that this guy, I forgot his first name, but he's a mathematician, and he actually created this algorithm. And I think they use his algorithm to calculate what is that size to should be assigned for those overlapped area, or even like basic diagram circle as well. Okay, so anyway, so there is a package called EULERR package. Same thing. I have already installed, and then I'm calling it here. And then from here, I'm calling that function. This is a little bit kind of like a tricky. You have to use this kind of like a thing. So what is this one, right? So again, I'm gonna fix this data frame name before I get into the error, and make sure it works okay. Ooh, it doesn't work. So, okay. So the reason it doesn't work is because this package expect the not underscore, the column name to be ampersand. Okay. So what I mean by that, so I'm going to just create the branch data frame. Okay. And then I'm going to call it like a 1 or something. And then change the column name to something that that particular package expects. So type new name, and then this one, Canada and ampersand. Okay, and then this one, USA and ampersand. And the same way, this one, ampersand, and then this case, I need a 2 under ampersand sign, and click run button. And then should be okay once I change this data frame. This one like I created as a data frame, branch data frame. So like I add 1 like that, and then go to the preview, boom. So now like all the circles come together. Ooh, it's very like nervous to do in this like live demo. Anyway, so here USA and Russia overlapping area is 816, and then here, Canada, Russia overlapping area is 1,371. So therefore, the size is different. Okay, so this overlapping area represent that the value, and then even like the no overlapping area also, like when you look at it, is the exact. In this case, like you have the exact same number, so therefore, it's the same size. Not on the overlapping area wise. Okay, no, sorry, overlapping the entire area. Okay, so this one is like 2,861 and so on. Okay, so now this is the Venn diagram. So either way, like it depends. Sometimes like this one, like when you have a bunch of like a diagram, it gets really confusing. So you might want to prefer this more like simple one, like just to give you the concept, and then like you have to read the numbers, or you want the circle or overlapping area itself to represent each number, and then I think this EULERR package is the way to go. Okay, so next up is a waterfall chart. Waterfall chart is it's being used for like a financial situation or a financial data or sales data. So basically what it is so you have like a revenue and the extra revenue. So at this point, you have the whole entire revenue is to be like 15,000. However, like you have the expense, like fixed costs, variable costs, and tax. You want to subtract that. And at the end, you have the profit, right? So like net earnings, right? So in this case, $105,000. So you want to visualize this data. So like you start with the sales, and then you might want to have extra service, like or extra revenue. So like that is actually $50,000. So that you go up. But next one is a fixed cost. So you want to minus it or go down $20,000. And then you have a variable cost, like another $15,000. It's not going up. It's actually coming down because subtracting. And then you get the tax. So like you want to subtract tax of $10,000. And at the end, you have $105,000 remaining. Maybe like you can call it like net earning or something like that. So this is called waterfall chart. It depends on if the number is a plus or negative, a positive or negative. And then you want to actually track down like how you increase, how you getting that numbers reduced. Okay. And at the end, usually the total or like at the, like whatever the remaining values. So there is a waterfalls package that can do exactly this. Okay, so let's take a look. So like if you want to do it here, waterfall chart, the data, like what type of the data you have to prepare. So data is something like this. Okay, so this one is each line represent each item or the metrics. Okay, so in this case, I have the sales and service. Service is basically like, maybe like we not only merchandise, we also provide a consulting service or something like that. So these are the revenue and these are the minus of the cost, expense, and tax. Okay, maybe sometimes you might have the data like this, like a bunch of the columns, and each column represent those like the metrics or numbers. In that case, you want to bring this one to that kind of a long format. How you do it? This is exactly what I did. This is called wide to long data for transformation. So how you do it is basically like you want to select whatever the columns that you want to actually bring to the kind of a vertical way. And then from the column header menu. And then this one is kind of called wide data. It's like kind of going to that horizontal way. And then so wide data to long data. Long data is kind of more like a vertical direction. So, and then I select the wide to long, and then selected the column or selected range either way. And then once this is exact the step that I was talking about. Okay. And then like you get that data format like this. So the key is to how you get that data ready, and then you can prepare the data in Exploratory. And once you have that data, notice this one. Here's 100,000, 50,000, and then these are positive, and from here is the minus values. Okay. And then like you want to do a call again, make sure you install this waterfalls package, and then ggplot2. ggplot2, you don't have to install. That comes with Exploratory. As a part of the installation, at the very initial step, it's actually downloading and installing. That's and ggplot2 is part of that our packages. Okay, so you don't have to. So make sure that you check what packages are there under the system or user tab. And then in this case, waterfalls, probably you don't have it, then you want to install. Okay, once you install, you want to call this function the same way. And the first thing is like you want to specify the data frame name. In this case, the plan is a data frame name. And then other setting here is main thing is like, hey, you want to have the total bar. What is here, like when I go to the preview, here, that's that total bar. Like what is that kind of like at the end, what number you get, okay? So, and plus is right now the default setting, so plus is kind of like a green, bluish color, and minus is the red color. You can change those formats as well. Okay, so you get that waterfall chart inside a node. Same way, you can have that in a dashboard as well. Okay, all right, so let's get to the next one, hierarchical clustering. And hierarchical clustering is, this is basically the one of the methods of the clustering. We're going to use this university ranking by country data. So this data is already, let's go to actually the data itself, university ranking data here. Okay, so I have already aggregated it. So original data was like each line is the university name. And then, but there's a column called the country. So like I aggregated it by the country. And then, like, maybe some country has like a bunch of schools. This is like a college. So like in Harvard, MIT, and so on. And then it has a bunch of metrics such as teaching score, international research score, citation score, and so on. Based on that, I forgot the exact name of the organization, but they report produce a report every year. And sorry, maybe not every year, every couple of years. Okay, so what I actually did though, that kind of quickly, so originally, this is like a name of the school, and then based on the metrics, they're ranked, right? And then after this, I aggregated it by the country. Okay, And then like each score, for example, teaching international research, these are kind of the same type of the metrics, but number varies. The scale also varies. Okay, like the average is different and the variance is different. But also some of the metrics, such as number of the students or maybe international students ratio and female ratio and stuff. So the scale units are different. So we got to be very careful. So therefore, what I did was like I standardized those numbers. Okay, so this is a step. Okay, you can standardize the number from the column header menu. I think under the numeric function, and then like you can normalize. Okay, and then you can do that multiple columns at the same time. That's why like I have only one step to do it. Number six step is that I use this population GDP data frame. This data frame has a population data. Then I have selected only the top 20 based on the population numbers. So these are the top 20 most populated countries. And then I use that to join, not here, where is that? Here. Join this data frame. But when I join, usually you do like left join, so like bring the extra column from like another data frame. In this case, I use that population GDP, which is already top 20 countries column, to filter that data. So what I mean is before this step, it's called a semi-join. So out of the bunch of the join type, I use a semi-join. Okay. So the reason I did it is because this one has a 71 rows. That means 71 countries. And when you have a bunch of countries and you use the hierarchical clustering, it gets not super, but it's confusing, right? So I wanted to limit 20 countries. How you want to limit 20 countries? That's where that top 20 populated this comes in. So I use that another data frame to basically kind of filter down to top 20 most populous countries data. Okay, and then selected that all the columns that like I want to use to cluster these countries. So my idea here is that maybe Japan is closer to, let's say, like Germany, or maybe China, or maybe like United States. Which country Japan is closer? How about like Australia? Which country Australia is closer? And based on that, based on these numbers, and maybe like there's some kind of like similar groups are in this data. That's what the clustering is. Well, hey, why don't you have clustering? Well, we have clustering when you go to the analytics. And then here is clustering. It's actually the top k-mean clustering. But we have only k-mean clustering at this point. But you can do is like, hey, you know what? Like I want to select all these metrics. Depends like which metrics you want to select. But let's say like for the simplicity, I selected all the metrics, and then I get the clustering result here. And here is like, I want to country assign that. And then like you can see which country are clustered together. So for example, show category value. So for example, Japan, I was talking about, Japan is closer to India and Iran and China. It looks like a kind of Asian countries, as opposed to here, this is like European countries and stuff, right? So this is one way to clusters. But k-mean clustering is as a K represent the number of clusters. So you have to set how many clusters you want to create. And you can, this is one way to do it. The hierarchical clustering, you don't specify any set numbers, and it will kind of instead give you the kind of a diagram that will tell you how data will kind of closer or not. So let's just do it to see like what this is. I'm gonna just preview it first, and then you get the idea. So here, this is like it's sort of like a tournament in a soccer game or whatever, right? So here, for example, here India, Japan, that's like next to each other. That means that it's very close compared to other countries based on those metrics that we gave. Okay, and then Indonesia, Spain, and Iran, China. So this is like we kind of saw already in the k-mean clustering. It's different metrics, algorithm, but at the end of the day, they both use distance calculation. So Euclidean distance calculation. So it's results tend to be similar. And then now here the United States, and then here is like Australia, Canada, and then there's like some European countries. So tend to be closer. Germany, Netherlands, Switzerland, they're like regionally similar. So maybe something to do with that. But So you can see sort of like a closeness of the pattern in the data being visualized by using this sort of like tournament or tree visual. Okay, so how did I actually set this one up? Here is that first, this one is, so this one, you don't need extra R package. So this comes with the base package. I think it's precisely the stats package or something, but that comes with a part of the R installation. So you already have that. You don't need to install anything. Therefore, you don't even need to go in this particular one because the stats package is always there in Exploratory. The important thing is that here, H class, hierarchical cluster, this function is the one doing that kind of clustering calculations, okay? Basically to draw those three visual. But before that, like you have to give the distance matrix data. So what's distance matrix data is? Well, you can call this function, but in the exploratory, how you do that, I can show you quickly. So the data is something like this, and I'm gonna just create a branch because this is just for the demo sake, and then here's the table. So what it is basically like we wanna create, calculate the distance among the countries because that's the one like we want to clusters, okay, by using these metrics, okay. So that means eventually like you have like a country like this, like a 20 rows, and also country columns, the 20 columns, okay. And then now like we have like every single combination of any pair of the countries, then like you want to have the numbers that represent the closeness or we call it distance. Okay, and this, so to do that, like basically, like if you select all these metrics, and then same thing, this like wide to long, and I select range, and then here I'm gonna just go with a default name, but something like this, right? So now like this is exact the same data, but in a different format. Okay, so it's called long format. So now like we have like Australia has 9 rows and Brazil has 9 rows and so on, because all those columns becomes now the rows. Once you do it, and then like basically like we can calculate the distance, how you do it. So like from the country column header menu, analytics and distance. Okay, so when you select the distance, and then like you can say like select the column. So country is the one like you want to calculate the distance, how you want to do it. Well, I want you to use key columns. The measure is the value. Okay, so this basically, I want to use these 2 columns to calculate the distance for all the countries combinations. Okay, then at this point, you can choose like a different distance algorithm. I'm going to go with the Euclidean like a default and click run, and boom. So now like what you are seeing is every single combination of the country that we have the calculation here. So this number is higher the number is, the distance is longer, so therefore it's farther. So let's say Brazil or Australia is actually farther. But for example, here Australia, Canada 1.43. The shorter the number, the smaller the number is, the distance is shorter, therefore it's closer. Okay. But this is not a metrics. This is actually long format data with the distance calculated. So now from here, when I select the country and the value, these 2 columns, I'm going to transform this long data to wide data. So long to wide, and click run button. So this is a matrix that I was talking about. So now like columns represent the country, but also rows represent the country. And every single combination is now is a cell. And then you see like same information of the distance. Okay, only the place NA is, itself. So Brazil is, of course, that's like, closest. It's almost zero distance. That's why it's NA right now. So basically, you want to have this data, okay, before you do this, before you use this H class function. But at this point, either way, like you do that transformation in Exploratory and then you start with H class, or you just call this dist function and then create this underscore matrix data, and then give it here. Either way, and in this case, I'm actually doing the whole distance calculation here, and then give that to HC class, and then temporarily preserve that data here, store the data here, And then you use something I call plot function. This is the kind of R, the typical function, and then give that clustered data or information. Okay, and then basically this one has already tree information, and then all it's doing here, the plot is kind of printing out that output, and therefore you go to the preview, and you get this format. Okay, the same way you can customize it to change the chart title or font size and so on. And another thing is you can have this in a dashboard, not just a note. In this case, I'm using note as a demo. Okay. Now, then, yeah, I think that's pretty much it. One thing about this clustering is like, now like we have 20, you remember like I somehow filter down to 20 instead of using that all the 71 countries. If you use all the countries, it becomes something like this, which is okay, if you want to see like all the countries and relationship and so on. But to me personally, like the more you have, it's actually making kind of like a more complicated to even read it. So it really depends, like which one it makes sense for you. Again, this is the hierarchical clustering. A lot of users actually prefer this clustering for some reason. So I get these questions a lot. So now you know how to do it. But to me, if you want to do the clustering, just again, like use the k-mean clustering and then just do that sort of a first exploration. And then maybe sometimes, this hierarchy clustering, might be the better way, especially for communicating the clustering or relationship, then use that. Okay. So that's it for today. So today's seminar is to basically like I wanted to demonstrate how you can extend the Exploratory's capability by using R script. One of the area you want to extend is the charting capability or visualization capability. So there are a bunch of R packages in the world. So all you need to do is like if you can't find a chart you're looking for in Exploratory, then you'll go search, type like R or CRAN or CRAN, CRAN, and then the package, whatever the chart name that you're looking for. You don't have to know the package name, just type whatever the chart name. And then usually it will give, you ended up finding it in the first couple of entries. Then make sure you go to the CRAN, CRAN website, and then find out like what the package name, and then go check the document and what function you need to use, but more importantly, like how to use it by finding an example. Okay, and then once you have that, bring in Exploratory, make sure before you use it, you install that package, and then you copy paste, and then change that configuration, especially like a data frame name and a column name. Okay. So that's it for today. Now you know how to use our script in a note and dashboard. I hope you're gonna have a great, more option in your toolbox. Okay. Well, again, so thank you for joining today's seminar, or thank you for watching. I hope to see you in the next seminar. Bye.